So if you remember back to hi, hello, welcome. If you remember back to the quotient of powers video, the last one that we saw in there ended up with a -2 in it. And what do we do when we have a negative exponent? So today we're going to be talking about what we do when we have a negative exponent. So if you see a negative exponent, that means that the base is on the wrong side of the fraction line. To correct it, you're going to move the base. Now remember what a base is. Over here, this is the A. This is the base, if you remember back to the first video. And this is the exponent. Exponents in the denominator move to the numerator, and vice versa. That means, and the other way around. It's a fancy way to say that. So let's take a look at a couple and see what we're talking about here. I have an x to the -3. I have 1 over x to the -3. This x to the -3 is on the wrong side of the fraction line. So we want to move it from the denominator to the numerator. When we do that, we can change it to a +3. So 1 over x to the -3 is the same thing as x to the 3. And I think this is one we should probably check using sliders. So let's give it a try. I'm going to use a variable other than x, y, or e, because those are defined in Desmos. So how about I'm Miss B, so I'm going to use B. And I hit the Shift and 6 for the little caret, and I'm going to make it b to the -3. I'm going to add a slider, set it equal to anything other than 1. How about 2? Now, b to the -3 should be equal to b cubed, and it is. We can see that both are equal to 8. If I change it to another number, they're still equal. So we've done that problem correctly. Now we have x to the -7th, and that negative sign indicates that the base is on the wrong side with the fraction bar, but I don't see a fraction bar. Well, this is another one of those invisible math things that we have to remember. The invisible denominator here is 1. And when we move this to the other side, that means the invisible numerator is going to be 1. When I move this x to the -7th to the other side, it will become positive, and x to the -7th is the same thing as 1 over x to the 7th. Again, let's try that, checking that in Desmos with sliders. So I've put in what I determined to be equivalent. I'm going to add the slider. I'm going to set it equal to anything than 1. And sure enough, these decimals match, and so we've done this problem correctly. So the last problem is one that we've seen before. It was in the last video when we did the quotient of powers. And we're going to always subtract the bottom one from the top one. Let's give it a try. X to the 2 minus 4 is equal to x to the -2. We discovered this last time, but we can't leave this like this. So we have to move this base to the other side of the fraction bar. And we're left with 1 over x squared. I feel like we should try one that's maybe a little bit harder. Let's try this one. We have m's, we have n's, we have p's. We're dividing, so I have the same base here, these m's. So I have whoopsie, I have m to the 4 minus 7. We have the same base here. On top is the 8, so n to the 8 minus 4. And we have this p. It's not divided by anything, so it's just p. What are we left with? We have m to the -3, n to the 4th, and p. But this m to the -3, this is on the wrong side of the fraction bar. This is on the wrong side of the fraction bar. Is this on the wrong side of the fraction bar? No. So that's going to stay on the top. Is this? No. It's also going to stay on the top. But this needs to move to the denominator. This is your answer. Let's check this one in Desmos and see if we did it correctly. So I've written the two expressions, the equivalent expressions, exactly as they were presented over here. This was what we started with. This is what we found. We're going to add sliders to all, and they should be equivalent. And this is why you cannot use 1. 1 is always equal to 1, no matter what power you raise it to. Let's put in 2, 3, and whoops, and 4, and see what happens. These should be equivalent, and they are. So we've applied the laws of exponents correctly, and we have all positive exponents over here. Everything's on the right side, and they're equivalent to each other. I hope that this video was helpful. Thanks for watching.